All right, pre-cal, I'm going to add just one more thing. I want to tell you in part 1 of the lesson for section 3, chapter 8, section 3. We talked about what a inverse is, right? You multiply an inverse by the actual matrix, then you get the identity matrix, and the order doesn't matter. Normally, that it's commutative, the order does matter, but for you have A inverse times A, you get the identity matrix. If you do A times A inverse, you get the identity matrix. So we just talked about what the inverse of a matrix is. Then we talked about how to find the inverse. The primary way we're going to find the inverse is through double augmentation. And so we did an example of that in the lesson for part 1. But now we're going to talk about how we use that inverse matrix to find the solution to a system like this. So the first thing we want to do is, if this is the system, if you want to write this down, you can hit pause, but I'm going to blast through it. So we're going to write this system. We're going to write this system as in matrix form. So we're going to say this is going to be, we're going to take the coefficients matrix here, which is 1, 3, -1. And this is 2, 7, -4. And this is 2, 9, -7. And we're going to multiply this by the variables we have, which is x, y, and z. And this is going to be equal to, and I'm going to leave myself a little bit, yeah, I'll do it this way. And this is going to be equal to -3, -16, 14. Now let's talk about it. Why is this? Why is what I've written down here the exact same thing as what I have up here? And just, right, it's just a system of equations with the variables in here. And this is now in matrix form, the same thing. Well, let's do it. If I multiply this, well, first of all, can you multiply? Can you multiply this matrix by this matrix? Let's find out. This is 3 rows by 3 columns. And this is 3 rows by 1 column. And if the number of columns of the first is the same as the number of rows of the second, we got it. It's feasible. It can be done. And the resulting matrix will be the number of rows of the first by the, right? And we cross those out because that's what you're checking to see if those are the same. And because they're the same, it can be done, which means the number of rows of the first and the columns of the second will be the, right? 3 rows, 1 column is going to be the result of multiplying these 2 matrices. Well, let's take a look. If I multiply row 1 by column 1, that's going to be x plus 2y plus 2z equals -3, which is our first line, right? Just for grins, let's do one more. But if I did row 2, column 1, that should be row 2, column 1's entry right there. That's going to be 3 times x plus 7 times y plus 9 times z equals -16, which is what I got. So, excuse me, this is the exact same thing, just written in matrix form. Now, the next thing I'm going to do is I'm going to find the inverse of this coefficients matrix. And we're going to use double augmentation. And then after we do that, we're going to say, now that I found the inverse, let's find out, what do you do? Well, you know what, even before I do that, let's do this. Let's we call this matrix A. Okay, and we're going to try to find the inverse of this. Now, what happens when you multiply A inverse? What happens when you multiply A inverse times A? And which, by the way, if I multiply the left side by A inverse, I'm multiply the right side by A inverse. Okay, now, what is A inverse times A? Well, we talked about that. We said if you multiply either A times A inverse or A inverse times A, you end up with the identity matrix. So let's do that. If I multiply A inverse times A, I end up with the identity matrix, which is 1, 0, 0, 0, 0, 0, 0, 1 times x by z is equal to A inverse and times this, we'll just leave it at this specific example. 14. Okay, sorry about that. And now let's do it. Let's multiply this identity matrix by this. So it's going to be, first of all, can you do it? It is a 3 by 3 times a 3 by 1. The two numbers in the middle, right? Number of columns and rows here are the same. So it's going to be 3 rows, 1 column, the result. Yes, it is. Let's do it. We're going to multiply row 1 by column 1 to get that entry, and that's going to be x plus 0 equals -3. So we're going to get the x value. We're going to try to find the x value. So this would be 0 times 1 times, say it again, 0 times x is 0, 1 times y is y, plus, I should have been saying, plus 0 times z is 0. So this is y, right? And this is 0 times x plus 0 times y times 0 plus 0 times z is z. So this is the equivalent of multiplying by 1 in the universe of matrices. This is like multiplying by 1. So if I multiply by the identity matrix, this just comes out to be x, y, z is equal to A inverse times this value, -3, -16. And this, I should have just made this a generic value. I should have just said this is matrix, you get the idea. Where A represents the coefficients matrix. And anyway, you get the idea. Okay, so that's it. That's what we're going to do. We're going to figure out if this is A, we're going to figure out what A inverse is. And remember, we want to find x, y, and z. That's our goal, is to solve this system. And so now we're just going to multiply A inverse by this, and we're going to get it. Well, let's find A inverse. And that's going to be the thing that's going to take the longest amount of time. So let's take a look at it. This is A. That's 1, 2, 2, 1, 0, 0. Remember, we set it equal to the identity matrix. I'll talk about it. 3, 7, 9, 0, 1, 0, -1, -4, -7, 0, 0, 1. And now remember, what we're trying to do is we have A dot I, right? We have the coefficients matrix on the left, identity matrix on the right. And then the goal is through row manipulations that we make this into the identity matrix. And then what's on the right will be the inverse. All right, let's do that. So first step is to make that top one a 1, hot dog. It already is. 1, 2, 2, 1, 0, 0. Now we got to make each of these entries below a 0. So we're going to say this is going to be -3 row 1 plus row 2. -3 times 1 is -3 plus 3 is 0. -3 times 2 is -6 plus 7 is 1. -3 times 2 is -6 plus 9 is 3. -3 times 1 is -3 plus 0 is -3. -3 times 0 is 0 plus 1 is 1. -3 times 0 is 0 plus 0 is 0. All right, now we need to make this entry a 0, so we can just simply add row 1 and row 3 together. Say that. 1 plus -1 is 0. 2 plus -4 is -2. 2 plus -7 is -5. 1 plus 0 is 1. 0 plus 0 is 0. And 0 plus 1 is 1. All right. Next step, we're going to make that into a 1, right? And hot dog it is. So now we have to make the entry below that 1 a 0. Here we go. It's going to be 1, 2, 2, 1, 0, 0, 0, 1, 3, -3, 1, 0. And now again, we got to make that into a 0. So what we'll do is we'll multiply row 2 by 2 and add it to row 3. Then I'll have 2 and -2. So I'm going to say 2 times row 2 plus row 3. That's what I'm going to do. 2 times 0 is 0 plus 0 is 0. 2 times 1 is 2 plus -2 is 0. 2 times 3 is 6. 6 plus -5 is 1. 2 times -3 is -6 plus 1 is -5. 2 times 1 is 2 plus 0 is 2. 2 times 0 is 0 plus 1 is 1. All right, now the Gaussian part is done. We have the main diagonals all 1, everything below it is 0. Now we have to work up the Jordan. Gauss-Jordan elimination. All right, so let's keep the bottom row the same. 0, 0. I told you this is the one that takes the longest amount of time is for the whole process. It's going to go lickety split after this. All right. So the next goal is to make that into a 0. We can multiply row 3 by -3 and add it to row 2. Then I'll have -3 plus 3. I'm going to go -3 row 3 plus row 2. There we go. Negative 3 times 0 is 0 plus 0 is 0. Negative 3 times 0 is 0 plus 1 is 1. Negative 3 times 1 is negative 3 plus 3 is 0. Negative 3 times negative 5 is 15, and 15 minus 3 is 12. Negative 3 times 2 is negative 6. Negative 6 plus 1 is negative 5. Negative 3 times 1 is negative 3, plus 0 is negative 3. All right, and onward. Need to make that into a 0. We can multiply row 3 by negative 2 and add it to row 1. Row 3 by negative 2. Here we go. Negative 2 times 0 is 0, plus 1 is 1. Negative 2 times 0 is 0, plus 2 is 2. Negative 2 times 1 is negative 2, plus 2 is 0. Negative 2 times negative 5 is 10. 10 plus 1 is 11. Negative 2 times 2 is negative 4, and negative 4 plus 0 is negative 4. Negative 2 times 1 is negative 2, plus 0 is negative 2. And we got our final step. One more to go. And we need, the last thing we need to do is make that into a 0, and then we'll have all the main diagonals 1s and everything above below 0s. We'll keep the bottom 2 rows the same, 0, 0, 1, negative 5, 2, 1. We got 0, 1, 0, 12, negative 5, and negative 3. And here we go. We're going to multiply row 2 by negative 2 and add it to the one above it. Negative 2 times 0 is 0, plus 1 is 1. Negative 2 times 1 is negative 2, and negative 2 plus 2 is 0. Negative 2 times 0 is 0, plus 0 is 0. Negative 2 times 12 is negative 24, and negative 24 plus 11 is negative 13. Negative 2 times negative 5 is positive 10. Positive 10 minus 4 is 6. Negative 2 times negative 3 is 6. 6 minus 2 is 4. All right. Now, you can see we started with the right-hand side being the identity matrix. Through row manipulations, the left-hand side is now the identity matrix, which means the right-hand side represents the inverse of our original coefficients. All right, now remember what we're doing. Going back, it's early in the morning, my throat won't take it, is we're going to multiply. And I talked about the reason why, right? A times A inverse is the identity matrix. You multiply this matrix by the identity matrix, that's the equivalent of multiplying by 1, and we're going to get X, Y, Z. And if you multiply the left side by the inverse, you have to multiply the right side by the inverse. So here we go. We're going to go A inverse, which is equal to negative 13. We just found it. We just found it right here. I'll box it. So we're going to take that inverse matrix, which is negative 13, 6, 4, and 12, negative 5, negative 3, and negative 5, 2, 1. And we're going to multiply that by negative 3, negative 16, and 14. First of all, is it possible? This is 3 by 3 times the 3 by 1. And sure enough, right? Columns of the first, rows of the second, same, so it works. That means the number of columns of the first, rows of the second would be the resulting matrix. All right, here we go. So this is going to be equal to, let's go ahead and do this. We're going to multiply row 1 by column 1 will be the row 1, column 1 entry. So that's going to be negative 13 times negative 3 is positive 39. 6 times negative 16 is negative 96. 4 times 14 is 56. And I've got, now we're going to do row 2 times column 1 to get the row 2, column 1 entry. It's going to be 12 times negative 3 is negative 36. Negative 5 times negative 16 is 80. Negative 3 times 14 is negative 42. And finally, we're going to do row 3 times column 1 to get the row 3, column 1 entry, which is negative 5 times negative 3 is 15. 2 times negative 16 is negative 32, and 1 times 14 is 14, which is equal to 39 plus 56 is 95, and 95 minus 96 is negative 1. Negative 36 minus 42 is negative 78, and negative 78 plus 80 is 2. 15 plus 14 is 29, and 29 minus 32 is -3. There we go. We just found, remember what it's equal to? It's equal to X, Y, and Z on the left-hand side. So we just are showing that X, the X value of that system would have to be -1, the Y value 2, and the Z value -3. Okay, that's a wrap. So that's the third part, which is how do you use the inverse to solve a system of equations. Here was our original system right there. Okay, that'll be a wrap, y'all. Catch you in class.